They say refraction, then the horizon is always refracted, and then Alberuni.
Well, they can't have a refracted horizon. The refraction that they're talking about, first of all, is not even talking about the actual light. They're talking about changing the size of the ball. Hence the 7.6R. What does that have to do with the light? That's the ball. You're changing the size of the ball to match your observation. Well, that makes no fucking sense.
The light gets refracted, chocolate.
Oh my god.
Yes, so then it's not physical, is it?
Nope.
Isn't your horizon supposed to be geometric?
There's two horizons. There's two horizons.
Where's there two horizons?
What's the definition of horizon, please, Brenda?
There's three horizons.
Now there's three. It was two 10 seconds ago. Now it's three. Jesus.
Why is Brenda?
Brenda, are you out of your mind? Seriously, like, are you like a crazy person?
Clearly,
there
for
are
real.
three definitions.
Look, do you even have to
I don't
Brenda,
I don't even want to accept
There's only
that.
one apparent location.
I don't even want to accept any of this gobbledygook. Listen, Brenda, you Google how to get the distance to the horizon. They tell you based on your elevation, put this in here, and the calculator will calculate how far the distance is. It doesn't say it'll calculate the distance, but based on atmospheric conditions, it could be there or it could be somewhere else. I'm not hearing none of that shit.
I don't know what you're talking about. There's three horizons: astronomical, geometric, and apparent.
Can anyone be bothered?
No.
Yeah, on a flat Earth, fucking goof.
What? There's no geometric horizon on a flat Earth.
So the horizon, which is an optical phenomena, is also physical?
I couldn't hear you.
So the horizon, which is an optical phenomena, is also physical?
The horizon is a physical phenomenon.
No, it's optical.
Well, everything you see is optical.
Well, clearly.
But I don't care about any of that. I really don't. Listen, the model is supposed to predict where the horizon is, and it's not doing that. You go to Google. You go to Google. Listen, you go to Google, right? And you type in how to get the distance to the horizon. It'll give you a formula. The formula will tell you, okay, this, and this, and this. This is where the horizon is based on this. It doesn't say anything about not knowing specifically where it is because of refraction.
Yeah, that's because most times it's not significant. You need to take into account.
This, I obviously agree with you, but I just want to throw in one simple point. Wait, hold on. Do you hear me? I just wanted to say one thing: 99.999% accuracy up to a certain altitude. I just want to make that clear, just for anyone who's not clear about that. It's not an exact formula, but it is a very, very, very accurate approximation. I know I'm being pedantic, but I just want to throw that in there.
Yeah, that's true. So the horizon that blocks boats, the bottom of boats, the bottom of buildings, mountains, etc., that horizon, right, that obscures things, or in the globe's case, obstructs things, that horizon is a hard number, right?
It's based on just the radius of the Earth or of the planet that you're on. It's
based on trigonometry using it's trigonometry based on the radius. I've seen the actual
How'd you get that radius? Sorry, how'd you get that radius, Brenda?
You measure the circumference.
How'd you do that?
You just go around the circumference. You measure it.
Wow, you're a clown.
So you just go around and measure with like a tape measure?
It's what people they did it with chains. They did it with chains. They literally went around.
She's not for real.
Oh, the chain gang.
Bro, wait, hold up. So someone measured the circumference with chains.
With
chains.
With geodetic, they were geodetic surveyors.
Geodetic surveyors don't measure shit.
Chains. They were
No, they don't. They don't. They take plane data, from the plane surveyors, and then they calculate how much curve there should be based on the radius. What are you talking about?
Geodetic surveyors measure the circumference of the Earth.
No, they don't. I just told you what I just told you.
Yeah, that argument's from 2015 from ZISIS, and when we looked it up, what they found out was they take the measurements and they apply it to a model, right? That's why they came up with because you can apply that to any model. This is an old ass argument.
Because people have known the Earth as a globe for 2,000 years. So yeah, they did.
How? Who?
For 2,000
years. Okay, and who measured it 2,000 years ago?
Eratosthenes measured it.
Oh, guess what though? Straight rays don't exist. Parallel rays don't exist though.
And by the way, your boy Neil deGrasse Tyson, he debunked your shit.
Parallel. They are.
Hold on.
And they are straight.
Damn it! Where's my phone? Hold on, I got a citation here somewhere.
Crepuscular rays are straight. Parallel.
Yes, crepuscular rays are parallel. They are.
Really?
Really. Our railroad tracks.
They look like they're at an angle to me.
Yes, Hank, our railroad tracks parallel.
So, now you're invoking perspective when it helps your argument. Now you're an expert on perspective.
Exactly.
Right.
Are they parallel or not?
Yeah, they're parallel.
But they look like they converge.
Do they?
Right?
Yeah, this is a really simple way to
So
everyone can.
That's what crepuscular rays are.
That's why I brought up the argument that your boy Neil deGrasse Tyson debunked that shit because it could work with a close and local sun and a flat plane. So what do you think about that?
He's wrong.
Oh, so you're smarter than an astrophysicist now. You think a dog bone's a clock?
He's just wrong.
Brenda.
He's just wrong. So what he said.
You got psychosis.
No,
you completely left the realm of reality. Dog bones are clocks. You got psychosis.
Yeah, dog
You
bones.
don't understand.
All animal bones.
Remember, thoughts are physical.
All animal bones are clocks. They count down from the moment.
Yeah, and
Wow. I mean, I've heard it recorded, but I never thought I'd get to hear it.
Come on, man.
Okay.
Oh my God.
Okay, calm down. The rocks from Mount St. Helen were millions of years old, even though it erupted like 30 years, 40 years ago.
I'm pretty sure that rocks are not inside animal bones. So I was talking about carbon. I'm talking about.
Yeah, we're talking about David made it.
My clocks are.
One more time. How are animal bones clocks?
They're
one more time.
Because they.
What about a stop sign?
Because they contain carbon-14 from the environment. And they begin to lose it the moment the animal dies, and you can measure that.
So that's a clock.
Carbon-14 clock inside the bone.
Yes, it counts down from the moment the animal dies.
If you assume that the exchange rate never stops being constant, but if there's a problem with the atmosphere, the decay rate changes, right?
For all animals, they're always at equilibrium with respect to the amount of carbon-14 in the atmosphere.
How could you know the past? You can't observe that in the past. So here's the thing about science. You have to be able to observe stuff like this to make statements. Otherwise, it's just your psychosis talking.
No, we can observe the past. We can do gas chromatography on bubbles found in ice cores and know how much carbon-14 was in the atmosphere hundreds of thousands of years ago. So we can know.
Wait, how do you know from that little sample the entire atmosphere?
Well, because bubbles contain air, and if they're trapped in an ice core, then you could sample that, and you can find out how much carbon-14 is in there. And then you can. So
But how do you know that was like evenly spread out through the atmosphere?
How did you measure the 100,000 years? How did you measure the 100,000 years?
Because ice cores are come in layers, like the rings on a tree.
Like dog bones?
No.
Yeah, I know. So
Like
how did they measure the 100? Then how did they measure the 100,000 years out of that?
You count the rings in the ice core. You count the rings.
That sounds really accurate.
It's also really accurate to know how much carbon-14 is in
That's
an
not
air
fucking
bubble.
accurate. I was kidding. I was kidding. That's not kidding.
You don't think counting is accurate?
God.
My word.
So snow is deposited on glaciers annually, right? It doesn't snow all the time.
Well, they're clocks too. So glaciers are
Yes.
clocks too.
Yes. And so the rings in a tree, those are clocks.
And the rings of the tree are clocks too?
Yes, because you can
What are donut holes in
you
them?
can count how old the tree is by counting the
How
rings.
do they tell the difference between the rings in the ice and the rings in a tree?
What isn't a clock, Brenda?
One is made out of wood and the other is made out of ice.
Yeah, so how do they tell the difference between the timing of the clock of the tree or the timing of the clock of the ice?
Well, they can correlate them by comparing different timelines.
No, how did they measure it? We're not going to correlate with what?
Yeah,
We're talking
they
about
can-
like how
they
did they
can
measure the
match.
difference?
They can
How did they make the difference in time between the two? How did they figure the difference in time between those two different methods?
Well, the ring on the surface of the ice core is today,
That
and the one
that
at the
doesn't
bottom
tell
is so many years
the
away.
time difference, bro.
What do you mean the time difference? The ring on the surface is today.
Well,
Just
you're
like-
claiming all this bullshit. So, like, tell us how they made the time difference between an ice ring and a tree ring.
You can compare them. You can take multiple samples of tree rings from different trees, and you can work backwards, and you can go back a few hundred or a few thousand years.
Okay, what did they use for the gold standard for that timing method?
They compare them. Then you can look at
What did they use as the starting? What did they use as the starting point?
They use today as the starting point, and then you can compare the width of the rings. Tells you whether it was a rainy year, a wet year, a dry year, and those form a
How did they
pattern.
measure how long? How did they measure how much time
Every
has
ring is-
occurred with
every ring
those
is a year.
individual things?
Every ring is a
Show
year.
us the scientific citation. Let's see the scientific citation on that, please.
One ring is a year. Because that's how trees work. That's how they grow.
And what is one ring on ice on a glacier?
1 year.
So they're both 1 year.
Right. Because snow only falls.
No matter how thick,
Snow
no matter how thick the ring is, they're both 1 year.
The thickness would be how much
In
snow.
ice, in ice and tree, you heard it here. You heard it here, folks. You heard it here first.
Heard what?
Rings on a glacier in the ice are measured in the same year that a ring in a tree is measured a year. So don't forget that you heard it here on the Discord, 24/7.
Really confused.
Flat Earth.
That's not really accurate though when it comes to tree rings because they'll have multiple rings in a year sometimes. It's not 100% accurate.
That's why
Work with us.
that's why dendrochronologist is an expert field. It's a field. It's a scientific field, right? So they have ways of telling. They have ways of telling.
They have ways of telling. Yes. We
Yes,
know. Ways.
it's a scientific
That's how
discipline.
they tell,
It's called
because they wouldn't be able to tell.
Yeah, it's called
They wouldn't be able to tell anything without the ways. They have ways of telling. So that's what they use to tell.
That's
is
why
ways.
you're an ex. That's why they're experts. I'm not an expert. But it's a field.
They're experts in ways.
It's called
ways.
dendro.
Damn sure.
It's called
That's the smartest thing
dendrochronology.
I ever heard you say.
Dendrochronology. is what the name of the field is. So do you want to get back to me schooling you on horizons and Earth curve? I'm done schooling you on this.
Hey, did you just fall down the stairs?
I fell off my chair. Literally.
Deluded, brother. You're
rolling
deluded.
on the floor, man.
Well, you could start by telling us what's the rate of curvature at ground zero. What would be the rate of curvature of the sphere?
What do you mean by at ground zero? That doesn't make the Earth curves everywhere.
Everywhere.
Right. What would be the rate of curvature? That's what I'm asking.
Well,
how can we test it?
You can test it by noting how taking measurements from a certain known height of an object far away.
Let's say 1 foot.
You can plug it into the Earth curve calculator, and then you have to know the lapse rate for that day.
Right. But I'm talking about what's the rate of drop, vertical drop from, let's say, 1 foot. How far should we be able to see?
It curves. There's no drop. Flat Earthers always talk about drop, as if and that
doesn't a ball drop?
So it's not falling away from me. When I say drop, I'm talking about falling away from me. The rate it falls away from me. What is that rate?
Well, over short distances, it's 8 inches per mile.
Square, or 8 inches per mile?
8 inches per mile squared. So over short distances, but if you go longer than say 100 miles, then it's not accurate anymore because it's not.
Wrong. It's accurate to 250 miles within a couple of feet, which is more or less every single sight distance test, every photo that anyone's ever taken. I mean, I don't know why you tell such obvious lies.
I guess my point would be, should I be able to see horizon 10, 20, 30 miles away from a 1 foot observation?
You might. In the black swan image, you can see one that's quite a ways away, and it's because it's being refracted.
Yeah, again, the problem you have then is that you're not claiming a physical ball anymore. You're saying, look, there's a rainbow.
No, we're claiming a physical ball.
No, but you're not, are you? The second you say refraction, you're saying, look, it's a rainbow.
No, we're not saying, look, it's a rainbow. We're saying that
yes, you are.
Refraction will cause things to appear in a different place than they would be without refraction.
Yes, everyone understands the excuse. The problem is the second you say refraction, you're not looking at a physical ball anymore. You're looking at a rainbow.
We are. Yes, we are.
No, you're not.
If I put a pencil in a glass of water, it gets refracted.
Yes, we know what refraction is.
But I'm still looking at a pencil.
So?
Right, so it's not a rainbow. It's a pencil.
Fine. If I was to put a pencil in a glass of water and then the pencil changes direction halfway, and to claim that it was actually like that, that is what you're doing with the black swan.
No, nobody's claiming that it's actually like that.
Yes, it is.
We're claiming that...
Yes, you are.
In fact, the distant horizon is being displaced, just like the pencil gets displaced. Right? The pencil looks like it's shifted over to
the Earth has a physical curve.
Shifted over to one side.
Yeah, you're saying the Earth has a physical curve that you can't see? That's retarded.
No, you can see the curve.
You're insane.
So navigators all this time have been using lighthouses that they don't actually really see.
They see the lighthouse. What are you talking about?
You just said it's not the real lighthouse. You said it's an imaginary thing that's being loomed up from beyond the curve.
I didn't say it was imaginary. I said the pencil that you see refracted in a glass of water isn't imaginary, it's real. It's just that the location is not its actual location. It's been shifted over to the right or the left in a pencil.
So how would a lighthouse function if that were the case?
Well, under many normal conditions, there isn't a lot of refraction, so it functions just fine.
No, it doesn't. Not under 1,000 feet at 40 miles. Sorry, brah.
It functions just fine under most conditions. At highly refractive conditions where you're looking at something 10 miles away from...
So it lifts the lighthouse up 1,000 feet?
Nobody's...
Bro, are you insane?
Nobody
that's
thinks
ridiculous. That's what you're saying.
Nobody thinks lighthouses get loomed up 1,000 feet.
Okay,
so
let me...
that we could replicate this to show what you're talking about? Like if we were to take a ball and put an object on it and
yeah.
Well, I think Brenda is saying that refraction would flatten the curve. Making it
appear. It would depend on
type
of refraction.
Like flatter than it should be. Is that what you're really saying, Brenda? What type are you referring to?
So you could look at...
You're not really seeing it. She's saying you're not really seeing it.
You are.
Well, let me see what she says. I want to entertain. I've looked into refraction, but I want to see what Brenda, how she kind of explains it.
So you are seeing the object. It's just where you judge it to be is wrong.
And how do we determine this? I mean, I did ask a question. I really am curious. What type of refraction are we talking about here?
Well,
is it terrestrial refraction?
Typically, be looming is one type, towering, stooping.
Okay.
And there's other types. So it's like if you go spearfishing, you don't.
Okay, so stooping.
If it's spearfishing, you don't aim for the fish where you see it. You throw the spear where the fish isn't because it's being refracted.
Right, through water, because water has a different refractive index than air. So I understand that according to Snell's law and everything. That makes sense. But this globe refraction that you guys are talking about, that doesn't make sense to me. And maybe you could explain it. Because it feels like you're just making an excuse for the Earth being flat, and you're saying that refraction is making the Earth look flat when it's not really. And I just don't believe that.
Well, different densities of air have different refractive indexes, just like water to air has a different refractive index.
Then how are you getting parallel rays?
The rays that come from the sun are parallel.
Yeah, but what does that have to do with the measure? What does that have to do with the measurement here on Earth, though?
We were talking about refraction. I don't know. I think you've changed the subject.
I guess I did. Whatever.
So with the Eratosthenes experiment, so we know.
No, that's exactly what the hell I'm talking about. What do you mean?
Right. We know that the rays of light coming from the sun are parallel. Therefore, it is not a close sun. It can't be.
So how? Okay, whatever. I don't even know how you guys do it.
No, I don't understand what the problem is. I'm just telling you stuff that is just ordinary stuff.
Because you're telling us bullshit. You talk out of your ass.
That you're here is the problem.
This is just ordinary stuff that you would learn in school.
Yeah, right, Brenda. When none of us ever learned any of that.
Well, maybe you should have.
I mean, to me, it feels a little bit post hoc. I understand refraction is a phenomenon. Stooping, looming, all that is a real thing. But as far as the way you're applying, because of course you know the Earth's a globe, Eratosthenes already knew the Earth is a globe, so of course you know it. So I feel like you're using that as your kind of axiom to then say that, well, refraction, obviously we're seeing the black swan, so it must be refraction. And I don't feel like that's really backed up by a lot of evidence.
You can measure refraction and the rate of refraction based on the conditions of the air, whether depending on its density. And then you can just measure the density of the air at a certain time, and then you can conclude that that faraway images are being refracted.
But that would be based on an assumption that the Earth is already a sphere, which I'm assuming that you're assuming, right?
But people like Aristotle knew that the Earth was round. Aristotle gave good arguments. He said that ships go over the horizon, and then also due to the Earth's shadow on the moon is always round. And from those, he concluded, along with other things, he concluded that the Earth was round. It's a globe. And that was Aristotle.
So how far back can, like, what's the maximum that the horizon can be pushed back original position?
I don't know. I don't know.
What 50 miles if that was the case?
Well, there's some mirage phenomenon where they've seen faraway cities be refracted.
No, I mean from 1 foot.
I don't know how far away it has to be. I think that the black swan image is a case of refraction, and the geometric horizon is in front, and the apparent horizon is in back. Right?
So I'm not understanding this. You're saying that the horizon's being loomed over the horizon?
Yeah, after the fact. So it's going up higher, back further up higher. So you're not seeing the water there?
No, I mean basically what she's saying is the refraction is causing a level plane up into the horizon.
It's not
exactly like perspective works.
No, nothing like that. That's not how perspective.
Exactly.
No, if it's curving up into that point, well then it wouldn't be the horizon, right? Like the horizon is where things get obstructed, where things go to get blocked, like field goals, right?
Things get obstructed by the geometric horizon, by the fact that the Earth curves. But sometimes,
right. So if the horizon is pushed back, there's no curve up into that point, right?
No, it's always curving.
Well, refraction aside, Brenda, how do we measure this constant dropping away from us? That was my original point. How do we measure it?
How do you measure the curvature of the Earth?
Yeah. How do we physically go out and measure it?
You would use different maths and observations and measure the curvature.
Right.
Right. So Eratosthenes did that.
With sticks?
Yeah. He compared one.
But I mean, that's a
on which
point,
land,
though, right? Because we could do the same thing with a close.
On which part of land do you?
You can't do it with a close sun because we know the sun isn't close.
No. I'm saying with a close light source.
Yeah, but it's not.
You
close.
sure can.
The sun isn't close.
Well, what do you mean it's not close? What's close?
This
is all just
What's the word close mean to you, Brenda?
It's all presuppositional, right, Brenda? So you know the sun isn't close because you know that the light rays are parallel, but of course one is based on the other. So if you don't accept one, you don't accept the other, and so it can be flat. Unfortunately for you, that is true. The whole framework is presuppositional.
That's not what presupposition even means.
Yes, it is.
Oh, yeah.
No, It's the
All right, what's the new definition of presupposition? Tell us.
It's something that you presuppose before something else.
Well, as far as refraction goes, you're presupposing
that's exactly what Crypto just described.
No, because you don't presuppose that the sun's rays are parallel. It's an observation.
No,
but you are presupposing.
No, you
you presuppose the distance to the sun.
No.
Yes, you do. You presuppose that. Yes, you do. Yes, you do. You presuppose the distance to the sun, and then you assume that the rays are parallel based on the distance to the sun. The whole framework is presuppositional, and I will read the definition of presupposition for you. A thing tacitly assumed beforehand at the beginning of a line of argument or course of action. It's exactly what you've done, and it describes the whole mindset perfectly.
But we don't assume that the rays of the sun are parallel. We observe.
You assume the distance to the sun.
No, we don't.
You didn't measure it, did you?
Eratosthenes didn't know how far away the sun was. He only knew that it was far enough.
And he still doesn't.
He only
yes. So he assumed that it was a minimum. He assumed that it was a minimum of 400,000 miles, so that he could get the assumption of parallel rays.
He didn't.
These are all assumptions.
No,
yes, he did.
The parallel rays are an observation.
Yes, he
did. You can just deny.
This is just
so he didn't assume. So he didn't say if this then this.
Go ahead and tell us how he. Go ahead and tell us how he tested to see if the rays were parallel.
He observed it. That's something you can just observe.
How did he observe it?
I don't know how he observed it. It's something that anybody can observe, though.
So how do you observe
Anybody can do it, but you don't know. But you don't know how.
Jesus Christ.
Well done.
Well, there'd be a number of ways, like the shadows of trees, the shadows of architectural columns.
A tree shadow is going to tell us how big the Earth is.
No, it will tell you that the rays of light are parallel.
They're
a
parallel.
tree shadow is going to tell us all that about a light.
Wait a second. They're parallel. I got Rice
we've just been talking
University.
about that.
Hold on a second. I got Rice University in a live stream. Rice, NASA, and another university right back to back at 38 minutes after the hour. Are those rays parallel?
The rays of light coming from the sun are parallel.
Well, not in these depictions. They're not.
Yeah, so?
Yeah, so they're not parallel.
No, they are.
Didn't you know?
Well,
Curie,
not in these depictions. They're not.
Didn't you know, Curie, that rays can be parallel, converging, and diverging based on the argument?
Oh, based on the argument, all at the same time. Okay, I get it. Get the fuck
exactly.
out.
Are those illustrations to scale?
To scale? Yes.
Doesn't matter.
No, they're not. No, they're not.
They are to
It
scale.
wouldn't matter anyway.
Yep. Yeah, they're to scale.
It's a red herring anyway.
Why would they fucking draw them?
It's just an illustration to illustrate a concept. They're not.
It's an illustration of non-parallel sun rays.
But it's not to scale.
By Rice University, NASA, and the other university, I don't know what it is, all of them are non-parallel. Fuck the scale. Doesn't matter.
The scale matters quite a lot.
Get the fuck out of here. You're a dipshit. What are dog bones?
Those are.
Oh, QE, Brenda actually just went over the whole dog bone argument again with us a few minutes ago.
They're the skeletal dog bones are the skeletal.
Yeah, they're skeletal remains. You're full of shit. Shut the fuck up.
And they are clocks.
Shut the fuck. Yeah, they're clocks. That's what we wanted.
That's it. Brenda knows what we want.
Is an animal is an animal's the amount of carbon-14 in an animal's body at equilibrium?
You don't know where carbon-14 comes from. You don't know anything about carbon-14. You're an
Doesn't
empty
matter
dip.
where it comes from. It comes from the environment. Everything around you.
Yeah, from the at environment. Yeah, sure.
Yeah.
So how can you tell that dog bone from the environment?
You're a moron. Demonstrated
Why?
countless times.
Why?
Why?
Yeah.
Well, DNA is made of proteins Dog bones are clocks. Donuts holes are evidence of space-time. You get the flavor here.
No, I said space-time is physical. It's part of the fabric of the
Yeah, you're a fucking idiot. Shut the fuck up.
Shoes are natural phenomenon.
Shit, yeah.
So-
How could I forget that?
I choose shoe.
Are they not made out of natural materials?
Shut the fuck up.
The hypothesis of a shoe is the shoe.
It's leather.
Shut
is it
up.
not?
Rakia, what the hell are you giving super chats for? Somebody who doesn't know what a roux is. I mean, that's